Okay, girls, so welcome to your last unit of the year. Woohoo! So this unit's going to be on electricity. We're going to go through a couple different chapters. So this first video is based on chapter 15, sections 1 through 3. I would highly, highly, highly recommend reading that section, those 3 sections, before you watch the video, or at least after, because I think it will help with your conceptual understanding. I would maybe read it more than once, just to make sure that you really understand what's going on. So here we go. So we're going to talk about electric charges. So here are some properties of electric charges. You have positive and negative. It's only 2 you can have. And like they always say, opposites attract. So like charges are going to repel. So if you have 2 positive charges or 2 negative charges, they're going to repel each other. Whereas if you have 2 unlike charges, like 1 positive and 1 negative, they're going to attract each other. Nature's basic carrier of the positive charge is the proton. I think you guys know that from chemistry. But protons don't move from one material to another because they have more mass, first of all, than electrons. So they're a lot harder to move because their mass is bigger. And because they're stuck in the nucleus. So they really aren't going to get out of there. Negative charge, I think you could have guessed it, is held by the electron. So gaining or losing electrons is how an object becomes charged. Electric charge is always conserved, so you can't create new charge and you can't lose charge. So it only has to be exchanged. So if one object receives 2 electrons, then that means that some other object lost 2 electrons. Objects become charged because negative charge is transferred. So electrons are the pieces that actually get transferred between objects. That's because they're lighter, so they're easier to accelerate, and because they're not stuck in the nucleus. They're kind of in the cloud, so they can kind of float around. The last property I want you guys to know is that charge is quantized. So what that means is that it's only in certain amounts. And what that is it's really just the electric charge of an electron. So electrons have a charge of negative E, protons have a charge of positive E, and E is 1.6 times 10 to the negative 19 coulombs. Coulombs is our new unit for charge. So you can only have integer multiples of E. You can't have half E or a quarter E or negative 0.75 E. You're only allowed to have integer multiples of E. And like I said before, charge is measured in coulombs, named after the guy who just kind of discovered charge first. So conductors are materials where electric charge can move freely. Most metals are conductors. So copper, aluminum, silver are really good conductors, which means that electrons are free to move around the surface. They can kind of just go wherever they want, and they move really easily. When a conductor is charged in a small region, the charge readily distributes itself over the entire surface. So if you put a bunch of charge at the corner of a piece of copper, it's going to, all of a sudden, all the little electrons are going to start to evenly distribute themselves through the copper piece. They don't want to stay in one little section. They're going to kind of like run around and make sure that they're evenly distributed. And that's because they're going to be basically have forces against each other because they're all going to be negative. So if you have all kinds of negative charge, they're going to kind of fight each other and they're going to spread out. If you have all kinds of positive, they're going to spread out. Insulators are the exact opposite of conductors. Insulators are materials where electric charge does not move freely. So this is things like glass and rubber. Those are examples of insulators. So when insulators are charged by rubbing, only the rubbed area becomes charged. So you can charge an insulator by rubbing it maybe up against like a metal where some extra electrons will jump onto the insulator, but they're only going to stay right where they jumped on. They're not going to distribute themselves throughout the material because they're not really as easily moved around in an insulator. Now, semiconductors are kind of what the word sounds like. They kind of let charge move around. And so they're kind of between insulators and conductors. Things like silicon, germanium, those are semiconductors. That's a word that you hear a lot nowadays. There's a lot of research going on like in the tech field with semiconductors. So electrons and charge can move, but not as easily as a conductor and it's not as difficult as an insulator. Okay, so there are ways that we can charge objects. So the first way, and these can get really confusing, so this is really the section of the book that I want you to read more than a few times, because the concepts can get a little bit lost. So charging by conduction isn't really too hard to understand. You have a rod, and so you can see in this little picture over here, you have a rod that has negative charge all over it. You take that negative rod, you touch it to whatever you want to charge, so this little sphere. When you do that, all the negative charges of the sphere are going to kind of jump over to this right side and go away from the rod because they have a repelling because they're the same charge. And so the positive charges will stay kind of near the side, so you can see that here, they'll stay near the negative side. But when that happens, the negative charge, the electrons that are on the rod, will jump over onto the sphere. And then if you remove the rod, so in this step you remove the rod, the negative electrons are now kind of trapped on the sphere, and so now the sphere has a net negative charge. So with conduction, the object that's being charged is always going to have this same sign charge as the object that was doing the charging. So since the rod was negative, the sphere is going to come out with a net negative charge. Okay, so induction is a little bit harder. I would suggest reading this a few times. These are the first two things you need to know before you talk about induction. If you have an object and it's connected to the ground, like to the earth, by some kind of wire or pipe that is conductive, remember, meaning that all the electrons can move freely. So if charge can move freely in the wire or the pipe that's connected to the earth, and then that wire or pipe is connected to an object, then that object is said to be grounded, which means that any net charge that will come out of there is just going to go straight down to the earth. That negative net charge is going to go straight down to the earth. The second thing you need to know before we do induction is a neutral sphere will have equal number of electrons and protons, meaning there's no net charge on the sphere. So you can see that over here they have equal electrons and equal protons. Okay, so the first step in induction is a negatively charged rubber rod or some negatively charged rod is brought near but not touching an uncharged sphere. So near a neutral sphere, it does not have to be negative. You could have positive and it would just do the exact opposite effect on the sphere. So for now, we're just going to pretend like it's a negative rod, but you can have positive. It doesn't have to be negative. The charges in the sphere, as soon as this rod is brought close to the sphere, the charges in here will start to kind of move around. You'll see the negative ones start to kind of like go this way away from the negatively charged rubber rod because they are being repelled. And so the negative guys are just going to kind of stick over there. And you'll notice that it doesn't show it in this picture, but the positive ones will kind of start to move to the left. So now when we look at it, we have extra positive charges over here near this rod because the negative guys have kind of scooted away and been repelled. And so then we connect a grounding wire. So that's what this thing is doing. This symbol always means ground. A grounding wire to that side where all the negative charges are. And so some of them will start to move down that wire and go to the earth. And so the sphere starts to lose some of its negative charge. The only reason the negative ones go are because they're being repelled by the negatively rubber rod. And so the positive ones don't go, just the negative guys will go down and ground. So they're going to go down to the earth. So they're out of the sphere. So now once we've grounded some of those negative charges, we remove the grounding wire. And we're left with a sphere that is now mostly positive, and so it's going to have a positive charge, so a net charge of positive. So the wire to the ground is removed. Initially, the positive charge on the sphere is non-uniformly distributed. And so you'll see that they're kind of like, they'll be kind of stuck like over in this area, all the positive guys, but then eventually they're going to go ahead and kind of spread out once you remove the rod. So like I said, once you remove the rod, that positive charge will evenly distribute itself around the sphere because they're all the positive guys are going to repel each other. So they all want to get as far away from each other as possible. So they'll get evenly distributed, and the same thing will happen with the negative charge. So you can see how they've all kind of like taken their little corners here. They're just going to stay as far away from each other as possible. And so the remaining sphere now has a net charge of positive. So something to remember about induction is you do not want to have any contact, and whatever the charge on the object that you bring near the sphere is, the sphere will become oppositely charged from that. So we brought a negative rod toward the sphere. and so the sphere ends up being positive. Unlike conduction, where you touch it with a negative rod and it becomes more negative. Okay, so this is kind of a long slide, but polarization is pretty simple. Usually, in most atoms, neutral atoms or molecules, the positive and negative charges are evenly distributed, and so the center of the negative charge and the center of the positive charge are the same spot, because they're all equally kind of spread out throughout the atom or molecule. When you polarize something, it means you bring some kind of charged object near this atom or molecule, and what it does is it causes the positive charges to kind of go toward negative or to go away from other positive, and the negative charges to do the same thing. And so what happens is you get like a realignment of the charges. So you get like most of the positive charge on one side and most of the negative charge on the other side, and so it's kind of split. And that's what happened, it looked like in the induction. So here's kind of an example. So a wall is going to be normally just neutral, and so the positive and negative charges will be all evenly distributed. But if you bring a charged balloon with all positive charge close to the wall will polarize. So its negative charges will come toward the positive over here, and the positive charges will repel and try to go away from it. So you see that the wall kind of gets split with all the negatives on the left and the positives on the right. So here's just a reminder, so go ahead and read this tip. You may want to pause your screen, your video. Okay, so I want to do a quick concept check just so far. So pause your video and answer the following question in your notes. I will tell you the answer when you're done. So go ahead and pause, read through the question, and go ahead and take a guess. Okay, so hopefully you decided that it was B, a negatively charged object. And the reason is if it can be attracted to a neutral wall because it will just polarize the wall. The negative charges will come to the surface. If it's a negative charge, the positive charges in the wall will come toward the surface, and it will be attracted to the neutral wall. The other key is that it's also attracted to a positively charged object B, and so that tells you that this thing must be a negative charge. It can't be positive because otherwise it would repel that positively charged object B. Okay, so I'm going to go ahead and pause this video. This video is over because it's going to be too long, so I'm going to have a part 2. So go ahead and you can close this video and open up part 2 of this section.